Good afternoon, and welcome to the National Invasive Species Awareness Week webinar series, hosted by the Southern IPM Center and sponsored by University of Florida, Texas A&M AgriLife Research, Auburn University, and University of Georgia's Center for Invasive Species and Ecosystem Health. Today we are proud to present Michael Brewer. He's talking to us today about the initiation of an integrated regional response to an invasive aphid pest of sorghum, from near-term to long-term management. Michael, if you'd like to share your webcam at this point, you should have an invite to do so now.
That would be fine. Thank you, Joe. Okay. Am I good?
You're looking good.
Great. Well, welcome everyone. It's my pleasure to participate in this. Let me see if I can get the toolbar off the screen so you can see the full picture. There it is. I'm chatting with you from Corpus Christi, Texas, in the southern area, and it's a little overcast. I wish I could show you palm trees at my windows, but the sun's not quite out yet. I hope everyone's staying warm. It's been a tough winter time throughout the U.S. Today, I'd like to chat with you about a team effort. A group of us were unfortunately saddled with this situation. A group of us, agricultural scientists and entomologists, saddled with the situation of a new invader to sorghum, a very large acreage crop throughout the South. And furthermore, here in southern Texas, we were saddled and shouldered with the issue that this was in the first area in which it was found substantially on sorghum, as opposed to on sugarcane and other locations. Well, so with that brief introduction and welcome, I'll continue on. I believe I have some capability here of people typing in questions. I'll let Joe in the background handle that, passing it to me. You're more than welcome to do so. I'll try to capture them on screen and see how they integrate with the flow of the talk. But otherwise, hopefully at the end, in fact, I understand that this is the last presentation. We could certainly, I am here for the duration, but I will promise you the formal part of the presentation we'll try to keep in the time frame. As Joe's mentioned, thank you. I want to, this first slide at the bottom, you could see a URL for more information on this talk, my email address, and Joe LaForest mentioned that this is going to be on YouTube, so here's the URL for that. Here's the outline of the presentation. I'll go through it step by step. Just pause here for a moment. Instead of chatting through them all, I'll let you take a look at the lines. But the concept is I'm going to go through some very near term, some early activities we did to address this invasive pest. And then getting into some long-term things. And in fact, what I will be talking about, the bridging. Even in the near term in addressing this invasive pest, we had some long-term considerations in mind. And first and foremost, what I'd like to do first is many thanks to what I referred to as the in-place team. What does the in-place team mean? It means the folks that are on the job. The vast majority of these people work at a land-grant institution throughout the southern states. I should say more specifically from Texas all the way up to Kansas in the Great Plains, and then from Texas all the way to Georgia and Florida. And as I mentioned, most associated with land-grant universities with a combination of extension appointments and research appointments. These folks particularly were instrumental in tracking the progression of this aphid, the quite amazing progression, actually. More thanks. I will share with you some specific experimentation done in Corpus Christi and a duplicate that was very successful done by David Kearns at Louisiana State University. The listing are the folks that did a lot of aphid counting once this insect was established here. I want to briefly mention the financial supporters, both current and I'll speak to strategic fits right now. In dealing with an invasive species, we really were able to take a grant advantage of existing people, as I mentioned, in many land grants. Here are all these states, and I shouldn't say take advantage. I should say they welcomed the opportunity because it is part of their job. Invasive species pest detection, and they all had a plant protection focus. The vast majority of them are entomologists. Some also were agronomists as well. Just really wonderful to track this invasion. Industry partners, here are the list of them. I want to particularly acknowledge Texas Grain Sorghum Board, who were very nice at providing some very early and quick financial assistance. My understanding, Louisiana's done the same, and I'm no doubt missing some other folks that did that throughout. Seed companies, agrochemical companies. On the public side, USDA NIFA Southern Region IPM has an emerging issues grant, just 1 year. We received some monies, 2 of the states. Links to existing programs. Just locally, I'd like to acknowledge we put some undergraduates to work on this activity. It's wonderful. Mid means midterm. We recently received notification of a USDA NIFA Crop Protection and Pest Management Applied Research and Development Grant for a 3-year period of time. And then long term, as you go through this introduction in regard to how do you finance dealing with an invasive species issue. In the near term, I'm showing it with you. In the long term, I will give you little glimmers of our thoughts about attaching ourselves to existing program priorities if needed. We would love to see this aphid disappear next year. We anticipate it will not. Let's go to the second example, bullet point, a case for regional IPM, the aphid and the damage. Let me give you a thought. In 2012, we did not see this. In 2013, we saw some of it. In 2014, we saw it dramatically. Many grain sorghums are excellent hosts. We can have a tenfold increase in aphids. Actually, that should say within less than 10 days. The plant injury, interestingly enough, is called by general plant decline associated with aphid loads. If you will, the plant it's exhausted over the amount of aphids sucking plant sap. They are sometimes referred, they are sap feeders. Fortunately, there's no detection of acute plant toxicity and no severe disease association. Some podoviruses are suspected. So yield loss is due to general plant decline and some harvest disruption due to the prolific honeydew. On the slide, you can see a founder's colonies, a winged aphid, starting a little colony. Not within weeks, we see this, readily seen. Notice how the background plant is green. So it's an excellent host in that it could bear a lot of aphid activity until finally, and unfortunately, into a very short period of time, we have a buildup of city mold, a lot of honeydew. We have an exhaustion of the plant if the infestation is bad. And then when the heads develop, we're talking about grain sorghum here, so the seed is important. There are honeys right in here, aphids right in here. This is a harvester, and all this, what looks like dust, are aphids. Aphids with their honeydew, and so harvest disruption is due to the honeydew, and people have to actually stop harvesting, haul the harvester back to the barn, clean it, and bring it back. There is expense there. So another case for regional IPM is range expansion. This was an impressive brand. I've been involved with a couple of invasive aphid species. I've read the history about green bug on wheat, and this is fairly impressive. This is fairly as impressive as green bug was decades and decades ago. In 2013 is where we first saw the detections of the light green. In 2012, there was no doubt some detections in South Texas, and at least one state, possibly 3 states in Mexico. I want to note for you is that in looking at the literature, this is a semi-tropical aphid that is somewhat unusual. Semi-tropical loving aphids, somewhat unusual in that aphids are typically more temperate climate animals. This one loves the semi-tropics, possibly the humidity. Look at the range expansion in 2014. It went from this core area of the light green to flew over with wind-aided movement all the way to the eastern seaboard, and actually late season of this last year made it up to a couple of counties in Kansas very late in the season. And I'll talk later about why we suspect this occurred. So some tools. What the ITPM tools, if people know that expression, are what are the natural controls or controls that we can manipulate that are out there for management. I would like to start with natural enemies, mention sorghum resistance, and then end with a brief on insecticides, then go on into how we can manipulate these. There are plenty of natural enemies. We didn't see in South Texas many in 2013, to be honest. That was our first official year of detection of the aphid on sorghum, but they were prolific in 2014. An unfortunate caveat that were most active pre-boot, that is, after the head development, after all the management decisions were needed, at least in regard to insecticides. But there is a good diversity of natural enemies, ladybugs, syrphid flies, more ladybugs and syrphid flies on the same leaf. Notice the city mold though. And parasitic wasps right here. And these little black things are parasitized aphids. And here's the adults that actually complete their development inside the aphid. And here's my first linkage to existing programs and future programs is that the dominant parasite out there is an aphid, very well known. And currently there's an NSF-funded activity with Jim Woolley at Texas A&M University and partners. And they automatically linked and said, please, we would like to identify what you find. So these linkages, I think, are very important when you're dealing with an invasive species. How do you grow with people in hand? And I have found that people in hand are really welcoming and are interested in contributing. And quite frankly, this led to a really nice activity in which Jim Woolley and I are going to be sharing a graduate student very soon on natural enemy impact on this aphid. Another tool, sorghum resistance. Many kudos to sorghum breeders and their rich history of banking seed going throughout the world, looking at diversity, and having this as a wonderfully accessed resource, and looking at its potential in this case for aphid resistance. They have a rich history of green bug resistance, and that was used as a starting point. There's quite impressive early work done. The need to fully incorporate the resistance that is putative right now but is likely occurring is a multi-year activity. This is going into the midterm and longer term development, but the activity was there. What I'm showing with you, all the people listed, are no new hires. The breeders, many kudos to them. Gary Peterson and Bill Rooney are with, again, Texas A&M University AgriLife Research. David is from Louisiana, and then many of us entomologists welcomed screening activities. Scott Armstrong with USDA ARS, and the rest of us either greenhouse or outside type screening activities. Now I want to speak to insecticides. For the near term, in dealing with a pest that went across the landscape so quickly and is found a wonderful agriculturally important host, grain sorghum, A very appropriate initial response is insecticides. We need to save yield potential. I will give you some stats fairly soon, I believe, from now. But in a nutshell, I wanted to share with you an update on the quick response. Standard insecticide efficacy work was done within the year in looking at this animal. UTC is the standard for saying when no insecticide was used. And I'm intentionally using product names. I would challenge you all to go on the website and look what these products are. But I have circled 3 that are showing, at least in this location, while we did this efficacy work, we did observations of natural enemies. There was reduced effects on parasitoids and ladybugs for these 3 groups, 2 of which are available now for protection of the crop against this sugarcane aphid. Transform, just literally today, we started getting information of a EPA Section 18 approval for Texas, Arkansas, Mississippi, and Georgia. Thank you, my colleagues on those states, for informing us. And I'm sure there is a cluster more of the approvals to come. And this Savanto has federal label approval for 2015. So we went from last year of some existing products that are troubling in their ability to control the aphid. You don't see this decline. That's substantial numbers of aphids. This is all on a per leaf basis, by the way. So whenever you see my per leaf information, multiply by 8 to get an idea of the load on the entire plant. Whereas here, look at this wonderful reduction, and staying to be reduced for at least 14 days, likely longer. So we have an initial toolbox and things in the works such as sorghum resistance, and possibly sorghum resistance as well as natural enemies will be able to work in harmony, hand in hand, in the long term. I'll give you a little more inklings of why we think so. Getting to the next area of what I wanted to share with you is early detection. We have an existing problem, a dramatic range expansion. How is that documented? It gets in the area of reporting to our growers who grow grade sorghum. Is this in your area or not? And they share reports, and we share them amongst the system to produce this map. I want to thank Robert Bowling, who is our new extension entomologist here in Corpus Christi, for being the recipient of all this information for that large group of people that I mentioned, and turning them into maps. This is an aggregate map that this last season, Robert produced these on an every 2-week basis, at least, sometimes more frequently, to track the first detections throughout the southern region. It was critical. And furthermore, I want to speak to specifically the southern locations. I already mentioned this is a semi-tropical aphid. And when the grain is not in the ground, there is certainly in the south where it has potential to overwinter. It is worthwhile, and I should say the deep south. I'll show you what I mean with those arrows. Inspect the remnant sorghum, the forage sorghum, drowned grass. This aphid must exist on green living plant material, and during the fall and the winter time when the green sorghum is not in production, there is remnant sorghum to look at, forage sorghums, and another sorghum species, Johnson grass. During the last 2 years, they've been found on Johnson grass along the Texas coast. I suspect now that they're the eastern seaboard, this would be relevant information to Florida. Found both in January 2014 and 15, then found in remnant sorghum January and February of both those years. And very soon, I know the growers in Tamaulipas, Nuevo Leon, and Coahuila in Mexico are booting up their ability to detect the aphids on the crop. The crop is by and large sown down there as we speak. Monitor then now, as I mentioned in Mexico, they're shifting to detection on the crop. And I want to state, because of the overwintering potential, with good coordination, the south does inform the north. And how can we do that? The crop is first growing in the south. The aphid has overwintering potential in the south. So it's very logical that we can be the first detectors, if you will, borrowing an expression. And at the same time, this is an extremely high value crop. This is a field crop, a large acreage system in South Texas. Last year, about 400,000 acres were grown. So we have to do this quickly. It can be devastating, and I mean the industry, the crop consultants and the growers, quickly but respectfully, particularly in first detection, or else if you do it thoroughly, you exhaust yourself. It's like looking for a needle in a haystack initially until you start getting strikes. At the same time, you want to do it frequently enough that you do not miss the big event, and that is this period of time. Through expert opinion, we formulated these recommendations. For the future, these are going to be fully tested this coming season, led partly by Nick Sider in Arkansas, and Norm Elliott with USDA ARS, and some other us will be volunteering to help determine if we got a good system here or how it should be tweaked. But I do want to share it's essential to have something immediate when you're dealing with an invasive species, and I relied on my knowledge of dealing with a few other invasive aphid species to come up with this with advice from good colleagues throughout the region. This is, again, a winged aphid. The ears are its babies. Wait a couple of weeks, you get this. Wait a few more weeks, you're getting to this issue at all, so, as well. So from very early detection to here, possibly as little as a month, you may possibly see this if weather conditions are correct. So you need to be able to detect quickly, but also go through, if you will, 400,000 acres of sorghum relatively quickly. That's a lot of sorghum. And here's what we came up with. I won't go into details of this. It is here. It will be archived on YouTube. I just wanted to get your perspective. You don't actually necessarily, when you're going quick, running through the field, if you will, look underneath the plant, towards the bottom of the plants. Look for detection of honeydew. It glistens off the sun. So it is possible to be very efficient. And then if colonies and honeydew toward the bottom of the plant are detected, we highly recommend a person go to what we call the twice weekly quick aphid checker. If there are few colonies and wing aphids, but only on the top of the plant, we still recommend you go to a quick aphid checker at least weekly. Things happen quickly. And this is something that we're recommending. We respect that individuals will modify based upon their needs and background, but this is something that we are suggesting. If no detection, you go back to your weekly quick detects. So you start at weekly quick detects, you detect, and then start off with the aphid checker, the density estimation. And here's our density estimation. Before head emergence, during the vegetative stage, before that seed head emerges, here's a way to estimate and compare against thresholds I share with you on an aphid per leaf basis, and very standard economic entomology. If you're above the threshold, spray within 3 days. The quick spray is very critical because these aphids reproduce so quickly. If you're below threshold on many leaves, definitely keep on expecting that twice per week. If you're below threshold with only a few of those aphids again found on the top of the plant, as I noted before, we still advise twice weekly spraying. And you can see this little diagram we have. We actually can print that out on a color printer, laminate it, and take it out to the field. People cannot count all those aphids. So we estimate categories. We put them in categories, take the mid-range, and take an average across 20 to 40 aphids per spot. Half of the leaves towards the top half of the plant and half on the bottom half of the plant. It's doable. Per spot, 2 people, it takes 5 minutes. When we get to the head emerges out. It's called the boot state, and then the stage of plant development, and then the head emerges out. When you're below threshold on the leaves, there's a situation. That is, you haven't made a management decision in insecticide spray position. You're now at boot stage or beyond. So what do we do now? If there's new colonies and winged aphids toward the top of the plant, certainly continue to check those leaves as stated before. If the expanding colonies are moving onto the stalk and head, estimate the density on the head. Consider need for head protection spray. I'm going to show you some economic thresholds in a bit, right now actually, and they're going to be based upon protection of the leaves. We have no information on the protection of the heads, and it's going to be complicated due to the honeydew buildup. Dealing with an invasive, it is a tough situation in that you have to proceed with best information now and then continue to work to modify it. The future, there's my first little thoughts on the future. So as we're doing this really straightforward, solid, foundational IPM, we want to have a vision for the future. In my first thoughts on concept development and links to other activities, I mentioned Jim Woolley and his colleagues for identification and natural enemy assessment. I want to talk a little bit more on the monitoring specifically here. Advanced detection and monitoring on large acreage systems is a big issue in regard to, again, how do you go across 500 acres of whatever crop. Remote sensing is a possibility using reliable, cost-effective platforms and informatics. I want to make a pitch to a good colleague of mine, Mike Sterrick, right at Texas A&M University, Corpus Christi. He's an engineer. He's a engineer and computer scientist. And he flies unmanned aerial vehicles. That's part of his work. And he flies them. If you look at this link and link to it, you will see that he now was instrumental in getting a permit to fly his drones on our land right here, where we have an endemic problem now with this aphid linkage. I welcome him out, and he went out. Once he got the permit from FFA, he flew his drone. So we got some wonderful work planned on, if you will, a shoestring budget-wise. He's in place here, I'm in place, but we could see some really great potential, and we've linked up again with myself, the director here, Juan Londovar. He's a really good advocate, USDA ARS. I want to speak about information distribution. I spoke about Robert Bowling, who every week or so put out these maps via email. There's ways to automate that process. Joe LaForest introduced me. Here's a website. Just initial exploration of this in regard to management and record keeping, and much more that I want to try to learn. Brian McCormack from Kansas State has a wonderful website to explore. So all these are existing activities, and they're very welcoming folks, and we'll see what goes on. I hope, as I mentioned before, this invasive goes away, as sometimes they do, but we have to be ready for its continual progress. I'm going to give you a brief little hardcore information on thresholds and then end it, hopefully right at about on time. So bear with me. I'm going to try to go through this quickly. This is too much information on this slide, but it's going to be archived. The threshold, an economic threshold, a la Larry Pedigal and others in developing of its concept. All we're simply trying to do here is determine when we need to spray for an insecticide when you have a very quickly reproducing aphid. It's not toxic to the plant. We can allow it to build up some, so we have an opportunity to not to hold off on the spray, to hopefully accumulate some natural enemies, to hopefully at a minimum not spray again and again and again. So this is a nice opportunity to do classic economic threshold work. There's our profile. Our first arrivals were at the 5 to 6 leaf stage of plant development. There's 8 total leaves. How we did the progress is that we did a foliar insecticide when we hit these different levels of aphid infestation on a per leaf basis using our quick aphid checker, and of course a no treatment control. This is the product we used, the one that now has its second year of Section 18. And here are the hybrids. Linking to the future, we certainly use the susceptible grain sorghum, which is commercially available, and also a green bug resistant sorghum as background to thoughts for the future. So now, susceptible sorghum, I'll be focusing on future thoughts as well. The measurements. We did that aphid checker. We estimated densities, just like I shared with you that we recommend growers to do. A little more hardcore here. We do it on a very small micro level. We looked at percent of leaves with city mold, and we looked at yield. IPM connections again. And so we not only look at these economic impact parameters, the agronomic side, yield, we looked at percent of leaves with these ebullient mummies, as well as ladybird beetles, adults, and larvae, looking towards the future. Results and pictures. I'm going to stay on this for a while and breeze real too quickly by on the data. I apologize, but I want to keep this in time and have a perspective. Anyone who wants to look at more depth, please go to the YouTube, freeze the screen, and look at it more. When we sprayed at this treatment threshold of 50 to 100 aphids per leaf on the susceptible, we had few aphids for the 14 days full out. Absolutely no injury, absolutely no yield loss, and a very considerable reduction in the number of natural enemies. These sprays do affect it, particularly when you kill the aphids very early on. There's literally not a lot of food in those plots. Aphid food, I should say. When we sprayed at 250 aphids per leaf on the susceptible, again, few aphids. Sooty mold was being detected. There was no yield loss, but abundant natural enemies. I do want to preface that no yield loss. We actually harvested by scissors. If this was mechanically harvested, we would likely detected some yield loss due to the honeydew buildup. And on our node, untreated to treated at 500 aphids per leaf, we had high aphids. Even our excellent product Transform could not reduce that heavy population further in plant development. The damage was highly visible. The yield loss was substantial. There was a natural enemy zoo out there, but certainly we can't have heavy yield reduction just to maintain the natural enemies. Note, this resistant with green bug resistance background was never sprayed in Corpus Christi. In the companion trial by David Kearns in Louisiana, it was sprayed only once. Really great future potential. I'm going to step these through now and note that this is just a repeat. Aphids, sooty mold, and yield. And I'll try to go to these bullet points. Again, less than 100 aphids per leaf resulted in low sooty mold and low aphids in the susceptible hybrid, and that susceptible hybrid are the pink bars. Little sooty mold here, little sooty mold here. But when you get to 250 aphids per leaf, the sooty mold goes up, unfortunately. On the aphids per leaf, from the 50 to 250 aphids per leaf, look at low reduction of the aphids. Unfortunately, too much sooty mold at 250, and at 500 aphids per leaf, entirely unacceptable. So there's good economic reason, as shown here by yield, to spray as necessary, but what the trick is, what's the appropriate level? On the yield, using our scissors, they were good from 50 to 250 aphids per leaf. We mechanically harvest. We fully expected this to go down some. At 500 aphids per leaf, very poor, and as poor as the untreated control, never sprayed. Note briefly the green bars. The green bars are the resistant hybrid Good yield, good yield, good yield, good yield, good yield everywhere. Maybe some reduction in the untreated control. Work to be done, certainly, but great potential. Not only that, these findings were stable. I showed you the data from South Texas. When we look at the classic yield aphid regression, number of aphids per leaf, we get a linear decline of yield as we have an aphid buildup. And looking at the loss estimate per 100 aphids per leaf, there's about a 2.5 bushel loss per acre. That's very economic when you have a yield potential about 50 bushels per acre. In Louisiana, his yield potential was about 65 bushels per acre, David's, and he saw the same linear effect. He had a bit more dramatic decline, 3.325 bushels per acre. But when you look at this, it's amazingly similar. I think we have an opportunity to suggest regionalization of the activities. Again, this is just for punch here. There's a lot of detail here. The green indicates that when it all comes to be said and done, at a cost of one spray or 2 sprays, at this market value of the grain, we have good potential to not have to spray on a single aphid. We could wait a while. And the while is, either 50 to up to 125 aphids per leaf. This is very important. This is not 2 aphids per leaf. This is doable. It gives you a time to detect it and make a good management decision. And this is for the susceptible hybrids. Life bodes well as there's more resistance coming in. This becomes even more doable and reasonable. Balancing. Let's go back to link that information with sampling and put it all together to end this. Estimating aphids per leaf will prevent spraying too early and maybe spraying too frequently. It's very tantalizing to say, well, let's just go and do a present sample, absence of this aphid. We would recommend not. If you do that, you're likely going to be spraying a good week, maybe even 2 weeks before you need to. The negative side of that is cost. The negative side of that is natural enemy reduction. If you have some that may try to get into the field, the negative side of that is possibly having to spray more frequently through the system. So we do recommend what we're just calling the quick aphid checker. And with the work next year, I'm sure it will be refined. Balancing now in the future. I mentioned to you wind-aided movement. My colleague Robert Bowling put this together amazingly, and this is all in preparation, so I really appreciate him sharing. And as you can see, high and lows, I'm sorry I am not a weather person, but the nutshell is that from the green to the red, just in this period of time, the weather events were conducive to significant spread in the eastern seaboard, and it occurred. This is very much, I want to give you tantalizing things for the future. Linking. Natural enemies, I already said to this in depth. I won't speak about this too much more other than saying we had natural enemy presence in the resistant hybrid, the green bars, everywhere, which is wonderful news, and in the susceptible hybrid, not to 250 aphids per leaf. So now we have to be careful. Now we're doing good at 250 aphids per leaf, but really the threshold shouldn't be there on the susceptible hybrids. So we have to compromise. For the future, note that parasitism was detected readily on the resistant hybrid. So there is a place for natural enemies for the future, if not now. At the conclusion of this, our recommendation to get this going is this threshold I mentioned. If you're sampling just once per week, that's all you can afford to do. You really need to consider the low side of the range. It's 50 aphids per leaf. If you can sample twice weekly, and certainly if you start detecting natural enemies, you may want to consider the higher side of the range. It's your judgment. we provide you the information upon which hopefully you could come up with your best strategy. Impact. Just some brief notes. Left this to the end. All the wonderful cooperating states. I'm in South Texas, so I gave an extra little line here. Because we were part of the core infestation area, the acreage infested was 100% last year. The losses, despite our wonderful, despite the wonderful work of growers for insecticide work, I want to shout out to them. The sprays were usually only one, occasionally two. There was an estimated 15% yield reduction, but without management, and there was fields like that, the yield reduction can exceed 50% easily. So here's the stats. We're right in the core area as well as our sister states in Mexico. It loves the Gulf Coast. And projection in savings due to all the hard work of the growers and the extension folks and the researchers in getting the word out. We had a very broad range, but it's got to be somewhere in the savings between 30 and 125 million last year due to yield protection with appropriate insecticide use. And that is actually backing out the insecticide cost. For the future, moving forward, and then I'll just go ahead and finish up, is that we have natural enemies. We have sorghum resistance to look forward to. We have hopefully advanced detection and monitoring systems being developed in its infancy, I'd say, but getting going on large acreage system. This situation is in the right place at the right time, with some linking up with existing activities. As well as I previously mentioned Jim Woolley's work, NSF funded. So we have some opportunities here. We have a case for IPM decision making. We have some recommendations, expert opinion, quickly got to be verified and checked and tweaked as necessary. Following a 2-month window of aphid infestation growth is critical. Absolutely critical. We have a regional threshold, good for most economic and aphid growth potential. We could do this. We have the sampling techniques available. And on the downside, the natural enemies are abundant, although occurring late. But again, the future bodes well for them and sorghum resistance to help out the system in the long term. For other webinars, there's that information. I showed you in the first screen the YouTube site. I want to end where I began. The many thanks. All these people throughout the South, up to the north in Kansas and across the South into Georgia, Florida, and the Carolinas. And I believe that's it. I want to again acknowledge the financial supporters, all the people in place, the industry, the links to existing programs. A shout out to the undergraduates working on this, and the midterm aspect to NEPA, their fairly new crop protection and pest management program, applied research and development. And on the long-term side, I wanted to tantalize you. Again, we hope this aphid disappears. There are instances like that occurs with invasive species. Our particular system doesn't bode well. We will assume, and we should assume, it will grow for a while and be persistent, possibly. So to be determined are other funding aspects, and we're exploring that by getting some initial data and linking to current studies and making an assessment if we're appropriate for other established programs. Thank you very much. I really appreciate it. I think I'll go back to the very first screen. That's all I got. And I'd be glad to turn it back over briefly to Joe to give instructions about how we should proceed.
There's plenty of time for questions. There are currently none in the queue. Actually, now we have one from Raul Medina. Have sexuals of sugarcane aphid been detected in the U.S.?
Okay. Joe, did everyone hear you?
Oh, I think everyone heard me.
Okay, I'll just repeat it. The question was from Dr. Raul Medina from Texas A&M. Have sexuals been detected in the system? I got to give you a brief background. You saw a slide that said they must exist on green hosts. That is currently at least detected. I'm not saying not present, but sexuals, as a determination of sexuals, no one has seen eggs. It appears to be all now asexual reproduction. We're blending over into the realm of some basic biology, and I would say I don't want to give you a definitive no. I do want to say that with this quick aphid expansion, it totally relied on winged aphids from asexual reproduction. Fair to say that. Sexual forms, I would have to defer a little from the original books by Dixon and aphid biology. I don't want to speculate too much. It's worth really first doing a great literature search, and to my knowledge right now, no sexuals have been formed, and I'd like to hear from the Florida folks. Probably is a good email shoot who are, we have a sugarcane aphid task force. If you put that question out on the task force listserv, I think you'll get more information than I can provide.
Okay. If anyone else has questions, you can welcome to either raise your hand or put it in the question panel on GoToWebinar, and we'll pass it on. I personally like to think that you've explained the topic so completely that they have every piece of information they could ever want.
Let me share with you something briefly. I'm showing it here as an example. I was given a presentation just earlier this week. Here's this MyPhillips website from Brian McCormick's, going from currently we'd be talking about boots on the ground and efficiencies. I really suggest that you take a look at it. Looking to the future, we want to link to this program. Joe has a program. In fact, Joe, I have a question for you. Can you briefly, or take as much time as you want, speak about what eddmaps.org is? Sure.
Edmaps.org is a site that was created to help pull together data from all different data sources where different groups may not have been communicating about where they've seen things. The original purpose for it was largely with invasive plants, with dealing with the National Park Service, Fish and Wildlife, Departments of Agriculture, did quite a bit with Florida with invasive pythons in the Everglades. Essentially, at this point, it has 2.6 million occurrence records in it. Only 1.7 million of those are actually point records. The data is available for people to use and look at, and we also provide visualization of those with county level or point level maps depending on what people want to be sharing. Not everyone wants to admit exactly where they've seen a pest, but often they're willing to say, well, I saw it in this county.
I'm showing you a county distribution map here.
Yep. Our maps look extremely similar.
Okay, and this was very hard work for one individual, many reporting and one individual putting it together. So your system could potentially do some automation of this?
Yes, that as soon as data comes into the system and is verified by someone or comes in from a verified source, the maps are updated in real time.
Fantastic.
So someone from my fields could report it, the data flows in through an API, we coordinate with them, and automatically the maps are up to date.
Well, Joe, do we have an invitation for you?
It's going to be fun. We look forward to it. We do have another question, actually.
Uh-huh.
The aphid could be more aggressive for the next season in Texas.
Boy, oh boy. Prediction. Hi, Raphael. I've been interacting with your email. So, boy, prediction. When you predict, you get your head chopped off. I won't give you my old-fashioned story about once upon a time from a good mentor of mine, who was a sugar beet entomologist. He 1 year did a prediction, worked 20 years on it. He finally said, I know exactly what's going to happen next year. He predicted a horrible flea hopper problem never existed. At least he was wrong the right way. You predict a problem, you predict a hurricane and it doesn't occur, at least everyone's safe. So in this case, it depends upon the overwintering potential. I want to say more is reasonably what should be done is the more southerly locations. Right now, we have actively fine. I could take a 5-minute break and come back to you and report to you sorghum on Johnson grass and even some remnant sorghum here 5 minutes outside my door. It will be readily detected into the Rio Grande Valley, and I can only assume that it's being readily detected on the 3 states in Mexico. I believe the grain is soon emerging, if not already out of the ground, and I would strongly recommend that people do the early fast detection in the states in Tamaulipas, Nuevo Leon. And I apologize, I always get that 3rd state name in Mexico. I mispronounce it. So I won't predict the specifics, but I will say presence is there now, and it's worthwhile looking closely. Let's hope for extremely more freezing weather to knock out that aphid, but we're pretty much done where far freezes here in South Texas. So keep a lookout, Raphael. It would be greatly appreciated. Let us know what you find.
We do have another question now. Are there biotypes of sugarcane aphids?
I will say, there's an excellent question. I gotta believe there is. I'll stick my neck out on that one. I believe the ecology and the host plant affiliation is telling us that there are, and then the genetics are catching up. Currently, what I'm aware of on the genetics works, there is very little variation that's occurring here, Florida, other places. But on the ecology, I want to share with you here something dramatic happened in 2013. It was found on grain sorghum. We've always had grain sorghum growing in South Texas, and we also, in the Rio Grande Valley, have sugarcane growing. My good colleague Raul Villanueva is responsible for this information, and we have a sugarcane aphid plot even here. We could now have grain sorghum right next to sugarcane. There's sugarcane aphid on sugarcane, and there's sugarcane aphid on grain sorghum. The sugarcane aphid on grain sorghum does not transfer to sugarcane. The colonies will die out. So that indicates to me that there's a difference in the beast. Some people are speculating now that this was distinctively a new introduction. It is certainly an invasive, and it's an invasive in regard to its spread on sorghum. So there's every reason to think that something very significant happened in 2013, expanded greatly in 2014, is on the cusp of expanding, at least maybe not in geographic range further, but in fill of all those counties in 2015. And I believe there's a tremendous amount of work. I know some genetics work have been done, but linking the genetics work with the known ecology of the animal.
Okay. We still have plenty of time for questions if anyone has any more.
Oh.
Seeing none, I'd like to thank everyone for attending this webinar as part of the National Invasive Species Awareness Week. And for those of you who I've noticed over the week attending multiple webinars, thank you very much. We had 10 in all for this year. The recordings of all these webinars will be available online at youtube.com/Southern IPM Center.